Hi everybody, this is your part 1 of lecture 11. In this part, you're going to see what is linear correlation. So by the end of this week, you should be able to explain what is bivariate data. You should be able to graph a bivariate data using scatter plot. And you should be able to identify the different types of correlation by looking at a scatter plot. And you should be able to calculate the product, moment, correlation coefficient to find the correlation. That is, you should be able to calculate the R value, which I'm going to show you soon. And you should also be able to interpret it. Okay. So first, let's see what is a bivariate data. As the name says, bivariate data. Yeah. So let's see what it is here. In science, we often want to investigate whether one variable influences another variable. Data is sometimes classified according to how many variables are in a particular study. So depending on the number of variables under study, the data may be univariate or bivariate. So bivariate data is when you are studying two variables, either to compare the two variables or to find a relationship between the two variables. For example, weight might be one variable and cholesterol might be another variable. If you remember, in week 1, we have seen some quantitative data, the cholesterol level of some adults, 30 adults, yeah? So that is a beautiful example of one variable, yeah? So you were just studying the cholesterol level, yeah? And you calculated the mean, median, mode, range, and all the summary statistics for those cholesterol level, for those data, yeah? So you were studying cholesterol level alone. Now what you're going to see is you're going to see how one variable, which is weight in our case, influences the cholesterol level of an adult. That is how one variable influences the other variable. How weight influences cholesterol level in an adult. Yeah. So that means we are studying two variables. So our investigation has two variables now, weight and cholesterol level. So that is called bivariate data. That is, to investigate such a link, we use data consisting of pairs of values of two variables, one for weight and the other one for cholesterol. Okay. So here, xi are the values of the independent or the explanatory variable, which is weight in our case, because weight is the independent variable here. And the cholesterol level depends on the weight of the adult. So cholesterol is the dependent variable. And y are the values for the response or dependent variable, which is cholesterol level of the adult here. Okay. So I represents the number of adults we have, or the number of data we have, I can say, yeah. Number of data we have collected. So it could go from 1, 2, 3 to n number of values. Yeah. So here what we see is y, the cholesterol level, is the dependent variable, while x is the independent variable, which is weight. Okay, so weight is the independent variable, cholesterol level is a dependent variable. Cholesterol level depends on the weight of the adult. Okay. So how can we represent such data? The best way to do that is using a scatter plot. Scatter plot will clearly show us the relationship between the two variables. So as you can see that weight is along the x-axis because it is a dependent variable, and cholesterol level is along the y-axis because it is an independent variable. And the cholesterol level depends on weight. Yeah. Okay. So let's take a data. Okay. So here I have a data of weight of adults along the first row, and the second row gives the cholesterol level for the corresponding weight. And the scatter plot is as shown. Okay, so what you do is you plot the scatter plot by, for example, 77. What is the value? 77, it is 4.4. So you plot the values for 77, the value is 4.4. Similarly, for 66, the value is 4.6. And so you plot your scatter plot. So what do we see here? The explanatory or the independent variable is plotted along the x-axis. I'm just going through it once again for you guys here. The dependent variable is plotted along the y-axis. And we also see that as you can see the trend here, as x increases, that is as the weight of the adult increases, the cholesterol level increases. So you can see the trend here. As weight increases, cholesterol level increases. Okay. So there appears to be a relationship between them, and we say that they are correlated. Okay. So now we have seen what is a bivariate data. We have seen how to plot a scatter plot. Now let's see the different types of correlation, because we have seen there is a correlation between the weight and the cholesterol level of the adults under study. That is, there is a relationship between the two variables. Now let's see what are the different types of correlation. Okay, so now we have three types of correlation: positive correlation, negative correlation, and no correlation. Okay, when data is positively correlated, the scattered diagram will show points scattered along a line where the slope is positive. That is, as you go along the x-axis from left to right, y value increases. As you go from left to right along the x-axis, y value increases. As you go from left to right along the x-axis, y value increases. In other words, as one variable increases, the other variable tends to increase. For example, the best example I can give you is, the more I exercise, the more calories I will burn, isn't it? So that is a positive correlation. Next, what is a negative correlation? Just opposite to that. The slope is negative. That is, as x increases, as you go from left to right, as x increases, y decreases. The variable y decreases. As x increases, variable y decreases. As x increases, variable y decreases. In other words, as one variable increases, the other variable tends to decrease. The best example I can give is, the more I exercise, the less likely I will suffer from any cardiovascular diseases or any heart diseases. Okay, so that's a very good example, isn't it? Okay, the last one, as you can see, no correlation. Look at that, how the points are scattered. If the bivariate data has no correlation, the scatter diagram will show the points randomly scattered in a cloud, just like this. Obviously, there is no relationship between the two variables. For example, the more I exercise has no relationship with how bright the sun is shining today. Yes, the amount of exercise I do has no relationship with the bright sun shining outside today, isn't it? So that is no correlation. Okay, now you know all the three types of correlation. Can you give me an example of positive correlation, negative correlation, and no correlation? Good, thank you very much. Okay, now how do you measure this correlation? How do you measure this linear correlation? Okay, Just like probability, we can measure the correlation coefficient, yes. But let me just give you the scale, what we use for measuring this, yeah. That is correlation between bivariate variables is measured on a scale between -1 to +1, -1 to +1. You can see 0 lies in between, yeah. So if the correlation coefficient is +1, that means that is a perfect positive correlation. That is, as x increases, y increases. 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 That's a positive correlation. Similarly, what is -1? As x increases, y decreases. 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 Perfect negative correlation. But actually, these don't occur in the real world. It's impossible, yeah? It's not an ideal world, isn't it? Okay, so what is that? 0. 0 means there is no correlation. That means the scatter plot will look like a cloud of points because there's no correlation between the two, yeah? Just like the example, how much I walk, that is the amount of exercise I do, and how bright the sun is today, yeah? Because it's really a sunny day today for me, yeah? Okay. And as you go from 0 to +1 and 0 to -1, the correlation increases, yeah? So that is the correlation increases, the positive correlation increases from 0 to +1, and the negative correlation increases from 0 to -1. So the magnitude of the correlation coefficient will give you the strength of the correlation. The magnitude will give you the strength of the correlation, and the sign, whether it is positive or negative, will give you the type of the correlation, whether it is positive correlation or negative correlation. Okay, but how can we get a value for this? We say that, okay, this is weak, this is moderate, but what if you have a 0.3? How will you know? How will you calculate this value, 0.3? How are we going to get a value for the correlation that exists in a bivariate data? And for this, you need a formula. And that is our one way of finding this correlation between two bivariate data or variable is the product moment correlation coefficient. So what we do is we use the formula. We use the formula to calculate the product moment correlation coefficient. Don't worry, you do not have to learn to derive this formula or anything for this module, yeah, because it will be given in the question. Because in real life, you can actually directly use a calculator to find the PMCC value, yeah? Or there are plenty of softwares and other modes of calculating PMCC, yeah? But for your module, for this module, you have to use this formula to calculate the PMCC, and you have to clearly state the steps you use to calculate PMCC. Okay, the PMCC generates a measure of correlation R, where R lies between -1 to +1. So that gives you the correlation coefficient R. Okay. So if it is around 0.5, it is weak. Between 0.5 and 0.85, or it is moderate. And between 8.85, 0.9 to 1, it is strong. Yeah. Similarly, it's a magnitude which helps us gauge the strength of the correlation. And the sign allows us to see what type of correlation exists, whether it is a positive correlation or a negative correlation. Okay, so let's take an example, the same example of weight and cholesterol level. So I have, along the x-axis, I have weight because weight is the independent variable, and along the y-axis, I have cholesterol level. Okay, so I have the data here. Now what I do is to calculate the correlation coefficient, I need to calculate xy and then find the total of xy. Then I need to calculate sigma x, sigma y, and n is the total number of data pairs. And I have to find the x square, then sum it up. I have to find sigma x whole square, that is x whole square, and then sum it up. Similarly for y, for the variable y. Yeah, so that's what I'm going to show you here. Yeah, so I've just calculated the x square here. 64 times 64 is 4096. Similarly, y square is 4.4 times 4.4, and xy, that is 64 times 4.4. So you calculate for each data pair or each bivariate data, and then finally sum it up, find the sigma. Okay. And then substitute in the formula and calculate the R value. So why don't you give it a try and find the value of R? Good. What did you get? Did you get R is equal to 0.78? Yes. So this indicates that we have a moderately strong positive correlation between the two variables. Yes. Okay. Now we have seen how to calculate a PMCC. Now let's see how to interpret the calculated value of the correlation. So we have seen that R is equal to 0.78. I'm just going to give you two examples here, and the rest of the different ways of interpreting I will explain it in seminar. Okay, I just wanted to get an idea of it. So for example, let me take this data. X is equal to 76 and 5.5. Yeah, when X is equal to 76, the cholesterol level is 5.5. Yeah. So now I'm going to change the 5. Which one is this? Okay, let me show you here. 75, 76, and 5.5. It's this data. Okay. So I'm going to increase 5.5. That, imagine that for this adult, the cholesterol level has increased to 6.5. So I am going to change that value to 6.5. So my new data will go up to here, somewhere here, isn't it? So let me just draw it. Yes. So what has happened? The data point has moved away from the scattered plot. It has moved away from the scattered plot. Yes. So what do you think will happen to the R value? Will the R value increase? That is PMCC, will it increase or will it decrease? Good. Yes, PMCC value will decrease. Why? Because the points are moving away from the straight line. For example, if this is your straight line, if you draw, oh, that's not a good straight line, the lesser the correlation, because the point is moving away from the scattered points, isn't it? I'm just trying to erase it. Yeah. So the further the points are to forming a straight line, the lesser the correlation. Okay. Now let me take another example to show you. So we have X is equal to 77, and now I'm going to increase 4.4 to 5. Yeah, 4.4. Which one is it? 77. So 4.4 to 5. Let's increase it. Oh, decrease, sorry. Yeah. 4.4 to 5. Increase, sorry. Increase somewhere here. Somewhere here. Yeah. So the point goes up. Look at that. So that means this is not there now anymore. Yeah. So what's happening? This is almost like, now the points are almost forming a straight line. Actually, this is not that much scattered if if this data value increases. Yeah. So PCC will increase because the closer the points are to forming a straight line, the greater the correlation. Okay, so we have seen 2 examples here. We'll see more examples in the seminar. I think that's all for today in this part 1. Yeah. See you in part 2.